This video was brought to you by the Teaching Center, UF's Learning Support Center, and the Department of Biochemistry and Molecular Biology.
This is the Dr. Long Study Guide, question 5. Why are stores of vitamins A, D, E, and K more stable than vitamin C levels? Well, if you look at the structures of vitamins A, D, E, and K in your notes, you'll see they're made up of these isoprene units, right? And they don't really have a lot of moieties that will make them soluble in water, so they have nothing to create hydrogen bonds with. So they are primarily hydrophobic, which means that they're fat soluble, which means that they're going to be a little bit hard to get to remove. Whereas vitamin C, also known as ascorbic acid, which I've drawn for you here, has a lot of these hydroxyl groups that it can hydrogen bond with, making it water soluble. That means that it's a lot easier to excrete. It can be taken out, flushed out through the kidney, and excreted along with other waste. So just to make sure you got that, so these are made of isoprene units. That's what's going to make them fat soluble. And for the last part, why might the ingestion of particular lipid pigments affect your vision? So you may have heard that eating carrots are good for your eyes, or is good for your eyes. And that's partly true, because carrots have this pigment called beta-carotene, which this is also in your notes. And this is a characteristic of pigments to have these long conjugated systems, so a lot of these overlapping pi orbitals, because when light comes in, it can excite some of these electrons to a higher state, and that's what gives off this strong color. So this is a bright orange color, and you find it in carrots and in sweet potatoes. So when you ingest this, your body breaks it down, cleaves it in half, and oxidizes it to get this molecule, which is retinol. You write that out so you guys can see this. So from this, cut this in half, oxidize it, and you get retinol. And we have this cis bond at the 11-12, the 11th and 12th carbons. And so like I said before, this conjugated system will absorb light, right? So in your eyes, you have these cones and rods, these different cells that will detect light. And the way that they detect them, at least rod cells do, they have this protein in their membrane called rhodopsin. And retinol is a cofactor. So light will come in, right? And it will isomerize this cis bond into a trans bond. So it goes from cis to trans, and that causes a conformational change, which then activates rhodopsin, which will activate a transduction pathway, which will ultimately send signals back to your brain, where the brain will decode these signals, and that is how we actually have sight.